Hello everyone, today I'm here to give you a quick overview of the navigation block program model in the PDI Builder. To ease the explanation, I will use the Embention eVTOL configuration template that is available on the Embention cloud, so it will be easy for you also to download it and to use it as a reference. We can access to the navigation submodules, and in the following program we can see how all the sensors are fused inside the AKF algorithm, which is used for the navigation in the road. We can see that the GNSS output is feed inside this block that weight the measurement and create an output which is entering then in the navigation block, which contains the AKF algorithm. We can see that also the magnetometer, the static pressure sensor, and the SRTM8 sensor are fed in this case in the navigation. It will be possible to use other sensor, as for example the LiDAR, and for what considered instead for the accelerometer and the gyroscope, it will be not needed to use any blocks, since the output of this sensor will be directly used by the AKF. I would like to show you briefly how the configuration of the different sensor used for the autopilot navigation is done. We can go on the sensor part of the PDI Builder, and we can see, for example, that for what concerns the accelerometer, Veronte Autopilot 1X incorporates 3 inertial measurement units that allow the system to measure different variables and that are the main source of the navigation. In this case, we can select one default sensor. In this case has been selected the ADIS, and if the other sensor fail, the measurement value will be the one of the default sensors. And we can select some settings here, but also choosing one specific sensor, we can deepen the settings that are correlated to that sensors. The same will be valid for the gyroscope. We are allowed also to choose external sensor and to increase the list of sensors here. For what concerns the magnetometer, we can use both internal and external magnetometer. In the case of external magnetometer, we can edit the rotation, which is relative between the autopilot and the magnetometer in order to properly rotate the measurement data. In the same order, we can set the dynamic pressure, and we can see that, for example, in this case the internal one has been chosen, the static pressure. We can configure the RPM and the LiDAR measurement. A better explanation of this is reported in the manual, in which all the settings are explained, so I invite you to check the manuals to have a better understanding of how to set properly and how to choose the sensors. Going back to the navigation block program, for what concern the sensor blocks, the converter between the output of the sensor blocks and the input of the navigation block and the navigation block itself, I invite you to read carefully the user manual to have a better understanding of all the settings that you can use to have a better fusing of all the sensor and to increase the precision of the navigation block. This was just a simple overview of the navigation block program, and to show you how and which sensor are fused for the AKF algorithm. For any further information, please don't hesitate to contact us. Thank you for your attention and see you in the next videos.